Hey everyone, welcome to part 4 of the video series on problems on factorization. Now, in this part, we have to again factorize algebraic expressions, and I have written here the identities that we'll be using while solving these factorization of algebraic expressions. So the first one is ax squared plus bx. You have to factorize it. Now if you look carefully, it's actually a multiplied by x multiplied by x, then plus b multiplied by x. Right, now this x here and this x here is a common factor in these two terms. Take this common factor outside of the bracket and write it as a squared, this is x multiplied by x. So write this as ax plus b. X multiplied by ax plus b. This is the factorization of this algebraic expression. 7p squared plus 21q squared. Okay, now this 7p squared is 7p squared plus this 21q squared is 7 multiplied by 3q squared. Right? So in this term, that is 7p squared, this 7, and in this term, that is 7 multiplied by 3q squared, this 7. This is the common factor in these two terms. Therefore, take this common factor outside of the bracket, and it is p squared plus root 3q squared. Sorry, p squared is equal to 3q squared. So this is your factorization of this algebraic expression. The third one is 2x cubed plus 2xy squared plus 2xz squared. Okay, now this 2x squared can be written as 2x raised to power of 3 can be written as 2x squared multiplied by x plus this is 2 multiplied by x multiplied by y squared, then plus 2 multiplied by x multiplied by z squared. Okay, this 2, this 2, this 2, this x, and this x. These two, that is 2 and x, are the common factors in these three terms of this algebraic expression. Take 2x outside of the bracket and write this as x squared plus y squared plus z squared. Okay, so this is your factorization of this algebraic expression because you cannot further break it down into its factor form. This is the one. Here you have am squared plus bm squared plus bn squared plus an squared. Okay, pay attention to these two terms and then these two terms. In this case, if you take m squared outside and within the bracket you write a plus b, then this plus sign, if you take n squared outside and you write b plus a, right? Now this b plus a can be written as a plus b because b plus a is equal to a plus b. And why are we doing this? Why have we done this? Because we want this a plus b as a common factor in these two terms. Now take out this common factor a plus b outside the bracket, like take common, then inside the bracket you will have m squared plus n squared. Can you further break it down into its factor form? No, this is the irreducible factor form now. You cannot further break it down. So this is the factorization of this algebraic expression. Lm plus L plus m plus 1. Now don't get confused by this bracket. This bracket has been put here to confuse you. Okay, so these two terms and these two terms of this algebraic expression. L is common in these two terms. Take L outside the bracket. So inside the bracket you have m plus 1 and this is already m plus 1. Now m plus 1 means what? 1 multiplied by m plus 1. Okay, so in this term that is L multiplied by m plus 1, and in this term that is 1 multiplied by m plus 1. M plus 1 is a common factor in these two terms. Let's take this common factor, and then this is L plus 1, the distributive property of multiplication over addition. Therefore, can you further break it down? No, this is the irreducible factor form of this algebraic expression. Therefore, this is a factorization of this algebraic expression. Y multiplied by y plus z plus 9 multiplied by y plus z. Okay, that's quite simple. This is y plus z, this is y plus z. In these two terms, this is the common factor, y plus z, the concept of common factors. So take y plus z, the common one, and put the rest within the bracket, that is y plus 9. Which property have we used here? We have used distributive property of multiplication over addition. Okay, now if you want this, you can write this as y plus z multiplied by y plus 3 squared if you want. Both these two are correct, whichever you want. So this is the required factorization of this algebraic expression. 5y squared minus 20y minus 8z plus 2yz. Okay, how can we do this? So for this, you have to remember factorization by the method of regrouping. This is 5y squared minus 20y. Now take this plus 2yz, write this as 2yz and minus 8z. Okay, take these two terms together and take these two terms together. Okay, 5y squared, so this is 5 multiplied by y, then this is minus 20, means we can write it as 5 multiplied by 4 and y, then this plus sign here. This is 2 multiplied by y multiplied by z, minus, we can write this as 2 multiplied by 4 multiplied by z. Okay, now this 5, this y and this y, take this common. These two are the common factors in these two terms. So 5y multiplied by y minus 4, then plus this 2 here, this 2 here, this z here and this z here, so 2z and y minus 4. Now this y minus 4 and this y minus 4, write this as y minus 4, and here you get 5y plus 2z. So this is the required factorization of this algebraic expression. Here you have 10ab plus 4a plus 5b plus 2. Okay, how to do this? Very simple. This is 10ab, so take these two terms together and these two terms together. The factorization by the method of regrouping. So this can be written as, this 10ab can be written as 5 times 2, if we take this one. So this is 5 times 2 times a multiplied by b plus 2 multiplied by 2 multiplied by a, and then copy this here, then this plus 5b plus 2. Now this 2 and this 2, this a and this a, so take 2a, these two common factors in these two terms, then inside you have 5b plus 2 plus, this is already 5b plus 2, so we can write this as 1 multiplied by 5b plus 2, right? Now in these two terms, 5b plus 2 and 5b plus 2, these are the two common factors in these two terms, so write this as 5b plus 2, and then you have 2a plus 1. Now these are the two, this is the factorization of this algebraic expression. This is the required factorization because you cannot further break it down, right? 6xy minus 4y plus 6 minus 9x. Okay, so what can we do in this case? Well, if we group these two together and these two together, now this is 6xy, write this as 2 multiplied by 3 multiplied by x multiplied by y minus 2 multiplied by 2 multiplied by y, control x and v. Then you have this plus sign here. This is 2 multiplied by 3 minus 3 multiplied by 3 multiplied by x. We are using the factorization by the method of regrouping. Now this 2, and this y and this y. So take 2y, the two common factors in these two terms. So inside you have 3x and you have 3x minus 2, and then this plus sign here. Now in this case you have this 3 and this 3. Take 3 common, so 2 minus 3x. Okay, now here you have 3x minus 2, but here you have 2 minus 3x. By just a little change, you can make these two factors common. How? This is 2 minus 3x, right? So we can write this as 2y 3x minus 2. Take minus sign outside the bracket, and this is 3. This will become 3x minus 2, right? How? So if this is 2 minus 3x, okay, 2 minus 3x means what? This is a bracket, 2 minus 3x. So we can write this as minus 3x plus 2. Any problem? No. Now this is minus 3x. We can write this as minus 1 multiplied by 3 multiplied by x, and this is 2, so this is minus 1, control x and v, minus 1 multiplied by minus 1 multiplied by 2, because minus 1 multiplied by minus 1 is 1, that's why you get 2 only. Now here this minus 1 and this minus 1, take this out, so minus 1, and within the bracket you have now 3x, and now this is minus 1 multiplied by 2, therefore this is 3x minus 2. So this is minus 1 and 3x minus 2, so this is 3 here. 3 multiplied by minus 1 will give you minus 3. That's the way, right? Sorry. Okay, so now this 3x minus 2 and this 3x minus 2, this is common, right? This is common. So 3x minus 2 and then 2y minus 3. This is the factorization of this algebraic expression. This is the factorization.